Okay, Bismillahirrahmanirrahim. So this is going to be our second lecture about data structures, and in this lecture we'll start from whatever we discussed in our last lecture. In our last lecture we talked about like what are data structures and why do we need to use data structures. We tried to make a point about that using a couple of examples. Then we talked about linear lists, like what are they are, and we looked at the implementation of an array-based linear list. Now we didn't implement it per se, like we didn't write live code and we didn't test it, but there was code on the slides, and I asked you to look into that code and try to implement something like that on your own. In this lecture, we are going to look at another representation of the linear list, and that representation would be the linked list representation. So we are going to use something that we'll call as linked lists to implement the linear list. Now there are different types of linked list. One is the singly linked list, the doubly linked list, and the circularly linked list. So once we start talking about linked lists, hopefully all these different types of linked lists would be clear to you. So let's get started. Let's start with the simple linked list. Like, what do we mean by linked list representation? So if you remember, when we were talking about the array-based implementation, we said that the elements of the array, like they are basically located contiguously or consecutively. So all the elements, they are together. Physically they are also together in the RAM, and you can access individual elements of the array using an index. Okay, the array, basically the array variable, it stores the address of the first element. So if you have any array, let us call that array as x, say for example. So x basically stores the address of the first element. Okay, so x stores the address of the first element, and you can access the remaining elements of this array by using an index. Any element, even the first element, if you have to access the first element of the array, you have to use an index. So the first element is at index 0, the second is at index 1, third is at index 2, and the last element of an array is at index size minus 1 or array size minus 1, however do you call it. Okay, so if the size of array is size, it can be say any value. It is usually predefined, fixed. So the index of the last element is size minus 1. Okay, so that is how you access individual elements of the array. Okay, so here we provide the index. Okay, sorry about that, I'm using a mouse, so at times it is not in my control, so that's why. So we access the individual elements of the array using an index. Okay. Now when we use an array to represent a linear list, so we have this facility of the index to access the elements in that list. Okay, and the index sort of gives order to the elements in the list. We use the index of the array to specify kind of the order of the elements in the list, in the linear list. Okay, in the case of linked list, we do not use any array, and the elements that we are going to use or that are going to constitute the linear list, those elements are not going to be located together in contiguous locations. So those elements can be anywhere. Those elements can be anywhere. And what we are going to do is each element is represented in a cell or a node, and each element, each node or element, it keeps explicit information about the location of the other relevant nodes. Okay. So for example, if we want to implement a linear list using the linked list representation, so what we are going to do is we are going to have multiple nodes or elements. Okay, we can call them nodes or elements or list items or items. These are different names or terms that can be used to refer to individual elements or items or list items in a linked list. So what we do is we use a separate element or node to store data, and not only does the node or element stores data, it also stores information about the next or the previous or both the next and previous nodes in that list. Okay, so that information, like which node comes after this node, or which node comes before this node, or which node is to the right of this node, or which node is to the left of this node, that information is explicitly stored inside that node. So the node, not only does it store data, it also stores information about other relevant nodes. We are using the term other relevant nodes. Those relevant nodes can be the next node, okay, the node that comes after it, or the previous node, or the node towards the right, or the node towards the left. You can call them by any name. So the left and right, or the next and previous, they define an order between these nodes. They define an order between these nodes. So whenever we have an ordered list, so that is the order is established by these facts that, like, one node has another node in front of it and another node behind it, or one node has a node to its right and another node to its left. Okay, so each node stores explicit information about the location of the nodes that come either after it, or uh, that are located behind it, or that are located to the right of this node, or that are located to the left of this node. So this left, right, next, previous, these this information about these nodes, that information is used to establish that order. So remember, we said that a list is basically a set of items E1, E2, E3 up until En, where E1 is the first item, E2 is the second one, E3 is the third one. So E2 comes after E1, E3 comes after E2, En comes after En minus 1. So that is what a list is. It has order or relationship between its nodes. Okay. So when that information is explicitly stored in a node, so we call that list as a linked list. Okay, and this explicit information about the location of another node is called a link. It is called a link. That is why it is called a linked list, and it is stored in the form of a pointer. In C++, we use pointers to store addresses. So at the address of the next node, the node that comes after this one, that information is stored in a pointer. And we can refer to that pointer as a link, because it creates a link between these two nodes. Okay. So from one node you can access or reach the other node. So let us look at it graphically. So this is what a list is basically. So a list is basically a set of items E1, or a set of elements or nodes. So we can call them as elements, we can call them as items or nodes or list items. Okay, so you can call them any all these terms are used to refer to these elements. Okay, and in this list, like EI is the general node, the ith node, and we know this relationship between these nodes. Like E1 is the first node and En is the last node. E2 comes after E1, so there is a relationship between them. There is the relationship of, like, orderly relationship between these two. So one comes after the other. Okay. So we can establish this relationship using explicit by storing this information about this relationship explicitly inside the node. Okay. So how can we do that? Each node has exactly one link field. Okay. Each node. So this is a graphical representation of these nodes. This is a graphical representation of these nodes. Now each node stores the element or data. So this is the element or data that it stores, and each node also stores explicit information about the node or the location of the next node, the node that comes after it. So after E1 we have the node E2. Now the information that after E1 we have the node E2. That information is stored in the node E1. Okay, so we have a pointer here. This variable is a pointer, and it stores the address of this node E2. The address of this node is stored here, so that's why we have a link from E1 to E2. We have a link from E1 to E2 because inside E1 we have information about the address or location of the next node, which is E2. So inside the node E1, inside the first node, we have this information about the node that comes after it, and that information is stored in the form of a pointer. A pointer is a variable that is used to store an address. So this variable stores the address of the node that comes after it. Similarly, this node, this is the node at position 2. Okay, it stores the element E2, and this node has explicit information or link to the next node, the node that comes after this node E2 in the list. So that node is E3. So it has the address of E3. And this arrow that you see, this arrow is here, this arrow you can call it as a link, and this link is created because E2 has the address of E2. So if we are at E2, or if we have access to this node, so we can access this pointer, we can read its value, and by using its value we can get to, or we can reach this node. Okay, we can jump to this node. So we have a link to this node. Why? Because we have a pointer which stores the address of this node, the address of node number 3. So similarly, in a linked list, every node has exactly one link field. This is a singly linked list that we are talking about. Singly linked list. Singly linked list means each node is linked to uh, a single node. Each link is node to one more node or a single node. So if we look at this node E1, this is linked to this node. It has only one link field. It has only one link field, which is basically a pointer, and this pointer stores the address of the next node. So this creates this link. It is called a singly linked list because it has only a single link to another node. Okay, so it has one link, or it has a link to just one node. It has a link to just one node. That is why it is called a singly linked list. Okay, and how is this link created? This link is created because this node has a data member which is a pointer, and that pointer stores the address of this node. That pointer stores the address of the next node. Similarly, this node has a pointer which stores the address of the next node, and hence this link is created. Okay, so this is a singly linked list. This is a singly linked list. Why is it called a singly linked list? Because each node has exactly one link field that is used to locate the next element in the linear list. So we only have just a single link field, and using this link field we can locate the next element. We don't have any way to go to the previous element. We cannot go to the previous element. If we are at E2, we don't know what the previous element is. We can only know what the next element is. So this is a unidirectional linked list. Okay, so the flow is in one direction. Okay, it is a singly linked list. So you either go from left to right or from right to left. You cannot go both ways. In a singly linked list we have this variable first. Okay, so first does not store any element or any data. It just stores an address to the it is just a pointer, and this pointer stores the address of the first node inside this linked list. The first node, the address of the first node of the singly linked list, that address is stored in the variable first. Okay, and this variable first is basically a data member or attribute of the singly linked list class. Okay, so it basically gives you an in. Through this particular pointer you can get into the linked list. You can access the first element of the linked list, then through the first element of the linked list you can access the next element, then through this element you can access the next element, then through this element you can access the next element until you reach the end of the linked list. Okay, now at the end of the linked list, this is the last node of the linked list. Now the last node of the linked list, the pointer that we have here, it is null, it is 0. So it does not point to any other node. That means we don't have any link that emanates from this particular node. Okay, so there is no link here. This is null pointer. It does not point to anything. That means we are at the end of the linked list. We are at the end of the linked list. So the last node En has no node to link to, and so its link field is null. So there is no node after En to which it needs to create a link. That's why the link field is null or zero. That's why the link field is null or zero. Okay, so this is a singly linked list, and this in this singly linked list, what we do is we have uh, all the elements stored in separate nodes. Inside a node we have two components. One is the data field, which stores the data, or here we represent those data, that the data by these elements E1, E2, E3, and the other field is the link field. The link field, it is basically a pointer, and this pointer stores the address of the next node, the node that comes after this node, so that like we have that order relationship between these different nodes. Okay, these nodes, like they can be located in anywhere in your RAM. Usually they are all on the heap memory, but they are not located contiguously. That is not guaranteed. So we need to, like, they are not array. This is not an array. This is not an array in any way. We cannot access these nodes via indexes. Okay, we do not have indexes through which we can access these nodes. These nodes are dynamically created. Okay, they are not created just like an array, like we create 100 nodes or 1000 nodes and then we start storing different elements of the list. That is not the case. These nodes will be created at runtime. Whenever we insert a new element into the list, we'll create a new node that will store the new element, and it will then we will then link it somewhere inside the linked list to the already existing nodes. Okay, so these are created at runtime. These are created dynamically. So these links do not have any relationship, just like the way there is between the elements of an array. So this is not an array. Okay, so we need to explicitly create this relationship. Every node must know which node comes after it. Okay, so this node E1 must know what is the address of E2. E2 must know the address of E3. Okay, and E3 must know the address of E4. E4 must know the address of E5. En minus 1 must have the address of En. And after En we don't have any nodes, so En does not need to know about any node. So that's why the link field here is null. It is zero. It does not create any link. So we have to create these links explicitly. And we'll do that when we start looking at an implementation of the singly linked list. Now, why is it called a singly linked list? Because we have a single link inside each node. Inside each node, we have a single link. Every node stores the address of one other node. Okay, E1, this node, if we call this node as E1, this entire node, so E1 stores the address of E2. E2 stores the address of E3. Okay, E3 stores the address of E4. So if you are at E1, you can only go to E2. If you are at E2, you can only go to E3. You can only go in one direction. E3 does not have any information about E2. It does not know whether there is a node that is behind it or not. That information you have to maintain it in some way. Okay. Okay. So now, in order to implement this particular singly linked list, so we need to create a class. That class can be called using different names. Like if you read different books, you'll find all these terms. So this term chain node, it comes from, say, the book by Sartaj Sani. Okay? So he uses this term chain node in order to refer to this node. This node, okay? This node is referred to as chain node. This node can also be referred to as simple node. This node can also be referred to as an item. This node can also be referred to as a list item. Okay, so there are different names that people use for this node. This is when we are going to implement a singly linked list class, we are going to basically create a class that is going to represent these nodes, okay? So that class can be chain node, list item, list node, you can name it anyways. So here I guess in these slides the term chain node is used, and if you see, it has these two data members, data, one field to store data, and the other field is the link field, which links it to the next element in the chain. And the singly linked list class, or the linked list class, that is basically a friend class of it, okay? So let us implement our version of this class. You can look at both these versions. That will help you understand different ways of doing the same thing. So let us create the singly linked list class, okay? Okay, so this is going to be our singly linked list, okay? Singly linked list. Okay, so the first thing that we need to do is we need to add a header file, because we need to provide declarations for our classes. So this is the first thing that we need to do. So let us browse. Okay, so let us save it as my classes. This would be our header file. Include it in all the releases of the project. Finish. Okay, so the first thing that we need to do is we need to create or declare our node class. Let us call it as node, okay? Or you can call it some other name, but let us call it as node. So this is going to be our node class node, okay? And it will have these two data members, private. One data member would be for data, so it would store data. Let us keep things simple. So it would store integer data. So this is data, okay? And the other would be a link to the next node. So it would be a pointer, okay, of type node. It would be a pointer of type node, and it would be, you can call it as link, or you can call it as next. So some people call it as next as well, next, okay? We can call it as link. It can also be called next, okay? So let us call it next, like we have on the slides. They call it link. Let us call it as next, okay? So the next item in the list, that is what we want to do. Okay, and we also want to specify that it has, this is going to be our node class. It is very simple. This is going to be our singly linked list class, okay? Singly linked list, okay? The name is a little long, but it's fine. Singly linked list class. This is going to be our singly linked list class. Let us make this singly linked list class as a friend class of the node class, so that we don't have to write those methods set data, get data. We want to keep things a little simple. So how do you declare it as a friend of this class? So inside the node class, we'll say that the singly linked list class is its friend class, okay? Friend singly linked list. So this class, node class, has one friend, and that is the singly linked list class. Is that fine? I guess that is how we do it. Acha. So what will happen? What is the effect of this declaration? Now the singly linked list class will have access to the private data members of the node class. That is the effect. Okay? That is what we want. Acha. Inside the node class, we'll have two private data members. Okay? Two private data members. What are those data members going to be? One pointer to the first element in the list. Okay? Pointer to the first element in the list. And what is that? It is going to be of type node. So this is a pointer of type node. and this is pointed to the first element in the linked list. Okay, and the second data member would be the size. Okay, so int say list size. So these are two data members that it has. These are two data members that it has. Okay. Acha ji. Now, what are the public data members that we want to have? So first of all, we want to have a constructor here. Okay. So singly linked list, it will have a constructor. Let's see, do we want it to have some arguments or not? Okay, so no, we don't need, we don't want to have it any argument. Here in this slide, like we are calling it as chain. You can call it as a linked list or a singly linked list or something like that. Okay. So here, this term again, it comes from Sartaj Sani. So if you look at that book, so there they use this terminology: chain nodes or chain items, and then chain. Okay. So this is the terminology that they use. So here we are going to use this terminology. So we have node, and then we have a singly linked list of nodes. Okay. Each node has, it stores data, and it stores explicit information about the next node. Explicit information about the next node in a pointer. This basically creates a link. It can also be called a link. Okay. It creates a link between two nodes. So this is the constructor. This is the destructor for the singly linked list class. Okay. This is the destructor. Okay. So destructor would require us writing some code. Acha. What are the other methods that we need to implement? Bool is empty. So bool is empty. So we need to know if the this is a const function. So if the list is empty, singly linked list, it will return a true, otherwise false. Okay. Then we need to have int length. We need to have a length method that would return the length of the linked list. Okay, so int length. So this would return as the length of the linked list, and it is also const method. Okay. Then we have the bool find method. So we need to find the element at position k in the list, and we need to return that element in the variable x. That is what the find method does. Okay. And it also returns some value, true or false, if we can find it, if we can find the element or not. So find, it returns, it gets two arguments. One is the argument k for position, and the other is for data. So that is a reference. Okay. So it is basically a reference. Let us call it as x. Okay. So find is also a const function. Find is also a const function. Similarly, we have the search function int search. So what does the search function do? I guess you give it an element, const, okay, const int x. So you pass it an element, and you want it to find that element and return its index, I guess. That is what it does. Okay. So we'll implement all these functions. I just want to copy this interface, and then we need to delete the what, the element at position k, and then we need to insert a new element after position k. Okay. So we need to do that, and each time we do that, we are basically getting what? We are getting a reference to the singly linked list in return. Singly linked list. So we are getting a reference. Sorry. Okay, singly linked list. So we are getting a reference to the singly linked list from which we remove this data. Okay, so the method is delete, and what are we doing in delete? What does it return? It returns the linked list. Okay, reference to the linked list. So the method is delete, and it receives two arguments. One is int k, and the other is a reference in which we can store the value of the node that we removed. Okay. So next one is the insert. So the insert also returns a reference to the singly linked list, and it also receives two arguments, int k and int constant, I guess. Okay, const int x. So this is the element that we want to insert. This is the element that we want to insert. Finally, we need to have this method, say print. We'll call it print. They call it output. Let us call it print. Okay, void print. So print would basically print the linked list. Okay, so this is the declaration of our linked list class. This is how it's going to look. Now if you see, like in the node class, we don't have any interface. The node class does not need to have an interface, okay, because this class is supposed to be used by the singly linked list class. For other programs or for other users, this class may not have any utility as such. So that's why we declared the singly linked list class as a friend class of the node class, so that it has direct access to its private data members. Okay, and we don't need to define those get and set methods for data and these nodes, etc. Okay. Now let us implement this class. So let us add another file. This would be a source file, and it would be stored here. Let us name it as my classes.c++. Okay. Okay, so here we are. This is our source file. So we'll need to do some printing here. So let us include the IOStream header file. Let us include the declarations that we did in the myclasses.h file. We'll be using the standard namespace, using namespace std. Okay, and now we can implement the class. So this is going to be the constructor of the singly linked list class. And this is how it's going to look. Okay. Now let me copy this. I'll need to paste it in many places. So this is the destructor of the singly linked list class. This is the is empty function. Okay, member function. Similarly, this is the length function. This is the find method. This is the search method. This here is the delete method. Okay. Similarly, this here is the insert method, and this here is the print method. Okay. Now let us get rid of these semicolons and replace them with this block of code, these pair of curly braces, so that we specify like we are going to write or create a block of code here. Okay. Now let us get back to definition, clarify some things. One thing you should know, like these do data members, what are they doing here in the singly linked list class? Now this data member, this is just a pointer. It does not store any data. it just refers to it just refers to the first node in the singly linked list class. Like if you look at this figure, say for example, it's not very clear, but this is the pointer which refers to or which stores the address of the first node in the linked list. All the data is stored in these nodes. Okay, so this is just a pointer. It only stores the address of this node. So initially, like when we create this singly linked list, so first is going to be null. It is not going to point to anything. And list size is going to be 0. So that is what is going to happen in the constructor. So once when we create a singly linked list, so it is going to be empty. The first pointer, it is going to point to 0 or null. Okay, so that is going to basically specify that this linked list is empty and list size is equal to 0, so it is empty. Okay, we'll write the destructor towards the end. Now how do we check whether a singly linked list is empty or not? Okay, so if the list is empty, that means first would be equal to 0. If it is not empty, first would not be equal to 0. It would be some non-zero address. So if we return something like this, if we say return first and then the equality operator is equal to 0, so what happens here is that the pointer first is compared to null or 0. Okay? So if both are equal, and if first is equal to null, true value is returned. If that is not the case, false is returned. Okay, so this function would basically tell you whether the singly linked list is empty or not. Just by writing this statement, we can do that. Similarly, the length function, it is just like it is interested only in the list size, so we just return list size. Okay, that is what it does. Okay. The next thing that we need to do is say for example, in order to make in order for these things to make sense, so I'll try to write first the insert function of the singly linked list class. Okay, the insert function. So like right now we assume that we have created a singly linked list class and that singly linked list class is empty. So what we want to do is we want to know how to do insertion, how to insert new nodes in this singly linked list. Okay, so let us first look at the code for it, or we can write the other functions as well. So let's see. These were the easiest that I just wrote. The print one is also very easy. We can write that as well. So let's write the print as well first, and then we can move on to the others. Okay, so let's say we have this list and we want to print it. So what are we going to do? And let us assume that we have, for the sake of this discussion, let us assume we have a non-empty list. Okay, we have a non-empty list. So if we have a non-empty list, then how can we print it? So what we need to do is we need to start from the first node. We need to print its data. Then we need to move to the next node, print its data. Then we need to the next node, print its data. Then we need to the next node, print its data. And we need to keep on doing it until we reach the last node. And how would we know that we have reached the last node? We would know that we have reached the last node if the next field, if the next field is 0. If the next field is 0, then we would know that we have reached the last node. Okay, because for all the other nodes the next field is not 0. Only for the last node the next field is 0. So we need to start from first, and we need to iterate through all these nodes. Okay, so that means we need to have some variable, and that variable will help us visit each node. Okay, so we would first visit this node, then we would visit this node, then we would visit this node, then we would visit this node. And by visiting a node, we mean that we would access its data field and print that value, access its data field and print that value. Okay, so that is what we want to do. So we need to have some variable in which we can first store the address of this node, then the address of this node, then the address of this node, then the address of the next node, the next node, then the next node. Okay, usually we declare a variable by the name of current for such purposes. Okay, usually we declare a variable by the name of current for such purposes. So current would be a pointer of type node. Okay, current would be a pointer of type node. Now the current variable would store the address of the current node that we are visiting, the address of the current node that we are visiting or that we are printing. Current has to start from the first node. So the address of the first node is stored in the variable first. The address of the first node is stored in the variable first. So this is a linked list. The address of the first node is stored in the variable first, and we want to visit each node so that we can print the values of their data fields. And in order to do that, what we do is we declare a variable current, which is a pointer of type node, and we copy the address of the first node into current so that it has access to the link field and the data field of the first node. Okay, it will visit the first node, and then what will it do? It will then move on to the next node and the next node and the next node and the next node. That is what it's supposed to do. Okay? Acha. So how is it going to do? So first of all, we need to make sure that current itself is not null. Okay? So while current and the first node, if the first node is equal to 0, okay, while current is not equal to 0, if the first node is equal to 0, if first is equal to 0, sorry, if first, the pointer first is equal to 0, that means the list is empty. That means the list is empty. There is nothing to print. The linked list is empty. There is nothing to print. Printing will only take place if first is non-zero. And since we have copied the address of first into current, so if current is non-zero, then the list would be printed. Okay? So how would we print it? How would we print it? This is how we would or visit it. Okay? So what we are going to do is first we are going to print the data in that node, the data stored in that node. Okay? So let us access that data. So current is a pointer of type node. Okay? And we hope that it would have the address of a valid node object, and we want to access the data and print that data stored in the node object. So how are we going to do it? We are going to say current arrow data. Okay? So that is how we are going to access the data. Since the linked list class is a friend class of the node class, that's why the linked list class can directly access the private data members of the node class. And since current is a pointer, so we are using the arrow member access operator. Okay? So we are accessing the data stored in the current node, and then, like, instead of printing a comma, let us print this arrow, this symbol. Okay? So we are basically printing that pointer, okay, or that arrow or that link on the screen, so that we know, like, after this item, the next item is this one, then the next item is this one, then the next item is this one, so on and so forth. Okay? That is what we want to do. Acha. So this is basically called visiting the node. This thing, printing the value of the data in the stored in the node, this is called visiting the node. Okay? Which is basically accessing and printing data stored in a node. Okay? So that is what we mean by visiting the node. So whenever we use the term, okay, visit all the nodes, इसका मतलब ये होगा कि आई वांट यू टू एक्सेस the data stored in each node. That is what we mean by visiting all the nodes. Visiting a node means accessing its data. So here we are accessing the data stored in this node and printing it. This is mean visiting the node. ठीक है? अच्छा जी. अब let us get back here. हमने क्या किया? We declared a variable, a pointer current of type node. Current को हमने value assign की first की. So current could refer to this node. Then we visited this node. मतलब इसका data हमने screen पे print कर दिया. अब हमें क्या करना है? Now we need to visit the next node. How would we visit the next node? Next node का address कहाँ पे? Next node का address यहाँ पे stored है. In the current node. Current node में ही next node का address stored है. किस चीज में stored है? Node जो class है या object है उसका एक attribute है next, which is a pointer to an object of type node. So उसमें वो address stored है. So after visiting this node, we need to visit this node using the current pointer. इसका मतलब ये है कि current pointer को हमने modify करना है. उसमें हमने इसका address store करना है इस node का, और इस node का address मौजूदा जो node है उसमें ही stored है. ठीक है? So we have visited this node. Now get ready to visit the next node. How do we get ready for that? So we need to copy the address of the next node into the current pointer. So current is equal to the next node का जो address है वो मौजूदा जो node है current उसका एक attribute है next, उसमें पड़ा हुआ है. So we say current is equal to current arrow next, यानी current को हम जो next जो node है उसका एड्रेस जिस पॉइंटर में सेव्ड है उसकी वैल्यू हम करंट में कॉपी कर रहे हैं. ठीक है? अच्छा, तो जब ये हम कर लेंगे तो हम फिर यहाँ पे आ जाएंगे. अगर वो नोड जो है वो एग्जिस्ट करता हुआ तो करंट वुड नॉट बी इक्वल टू जीरो. इफ इट इज नॉट इक्वल टू जीरो वी वुड विजिट दैट नोड, प्रिंट इट्स वैल्यू, प्रिंट दिस एरो. ठीक है? और उसके बाद फिर current would move to the next node. फिर हम next node पे जाएंगे. ठीक है? So this is how we would basically print a linked list. ठीक है? This is how we would print a linked list. And this code is something that is very useful. You are going to repeat this code over and over again. Almost हर चीज में आपने इसको repeat करना है. ठीक है? अच्छा. This is how we print the list. ठीक है? अब आगे और methods को देख लेते हैं कि वहाँ पे हम क्या करते हैं. So let us get back to this presentation. Okay, this is the destructor. ठीक है? Destructor को we'll write it at the end. We'll come back to this code. Length. So length को हमने we simply said क्या कहते हैं? We simply said this thing. Simply we said return the value of the attribute list size. ठीक है? This is one way of doing it. So we have to maintain list size. इसको हमने maintain भी करना. ठीक है? Maintain से मुराद ये है कि whenever we insert a new node into the linked list, we have to increment it. Whenever we delete a node, we have to decrement it. So we have to maintain it. So initially it is zero. And once we start inserting, we will increment it, and when we start deleting, we will decrement it. So this is one way of doing it. Or you can calculate it. You can calculate the length of the list. ठीक है? So how can you do that? You can do that as well. ये जो code है ना, this code, this will help you. So you start here. Inside this loop, you have to like increment a variable. So that will basically give you the total number of elements in this singly linked list. It's the same loop. इसी loop को आप use कर सकते हैं in order to find out or calculate the length of the list. ठीक है? But if you keep track of the list while you are inserting new nodes and deleting existing nodes, so then you don't need to calculate it. You can do it there as well. Acha, this is length. Find. What does find do? So find, what it does is it basically gets you the kth element. So whatever is the kth element, it reaches there and then it basically accesses its value, and after accessing its value, it copies that value into the variable x. That is what it does. Okay. Now, how does it do it? So let's see how does it do it. Okay, so let's get back here. This is basically find. Find क्या करेगा? It will find the kth element in the linked list. It will find the kth element in the linked list. That means you have to traverse through the linked list. Traversal means कि हमने linked list के start से शुरू करना है. If this is the linked list, somebody asks you कि third element को access करो. That means कि first से start लेना है. This is first, then you'll get to the second, then you'll get to the third. When you are at the third element, then you will access that element and copy its data into some variable that is provided to you for copying the data of this node. Okay? That is what it does. And if you can like find it, you have to return true. That is what you have to do. If you could find this element, if you couldn't, then you return false. Okay? Actually, so how are we going to do it? That means we need to traverse through this element, this array, this list. ठीक है? हमने शुरू से start लेना है. So जब भी आपने traversal का काम करना हो ना, traversal means visiting each and every element of the array or some elements of the array नहीं of the list or some element of the list. That means traversal. So you have to traverse at least k elements. ठीक है? k अगर 5 है तो मतलब ये कि पांचवें नंबर पे जो एलिमेंट हमने उसको रिटर्न करना है. पांचवें नंबर पे जो एलिमेंट है हमने उसको रिटर्न करना है. ठीक है. So how are we going to do that? ठीक है. पांचवें एलिमेंट को एक्सेस करना है. How are we going to do that? So we have to start from the beginning. So we need to declare the variable current. It will help us move from one position to another position. And current basically, this is a variable that tells us about our current position. It is basically, it stores or refers to current position in the linked list. It basically tells us about our current position in the linked list. So we'll start from the first. We'll start from the first node. ठीक है. So current में हम पहले node का address copy कर लेंगे. Now what do we need to do? So depending upon the value of k, if k is equal to 1, ठीक है, so we need to, like, we don't need to go any further. That means कि पहला जो हमारा एलिमेंट है वही हमें चाहिए. So we would return that element. ठीक है. But if k is greater than 1, so then that means we need to move in that list, and we need to reach the kth element, and after that, like, we are going to do something. So I'll need to keep track of my current position. One is, एक तो ये current pointer है, ये तो हमें एड्रेस देता है. दूसरा लिस्ट में हमारे पास पॉइंटर्स की अहमियत इतनी नहीं है. पॉइंटर्स को तो हम यूज़ कर रहे हैं फॉर इंटरनल इम्प्लीमेंटेशन. लिस्ट में तो इंडेक्स चलता है ना, कि इस वक्त मैं पोजीशन नंबर 1 पे हूँ, 2 पे हूँ, 3 पे हूँ, 4 पे हूँ. हमें पोजीशन नंबर k पे पहुँचना है. पोजीशन नंबर k पे पहुँचना है. सो आई नीड टू कीप इंडेक्स, कीप ट्रैक ऑफ द इंडेक्स इन द लिस्ट. फॉर दैट आई नीड एन इंटीजर वेरिएबल. ठीक है. तो i इज इक्वल टू, इनिशियली मैं इसको 1 कर देता हूँ. ठीक है. सो why is it 1? Because the first index in the list is 1. ठीक है. So हम index number 1 से start ले रहे हैं. So this I basically, it keeps track of the index of elements in the list जिनको हम visit कर रहे हैं. ये जो current है, ये तो pointer है, ये हमारी current position का track रखता है. But this is our internal representation. The user has nothing to do कि आया हम internally arrays को use कर रहे हैं for implementation या pointers को use कर रहे हैं. ठीक है. The user is more concerned with this index कि मुझे 5वें नंबर पे element चाहिए, kth element चाहिए. ठीक है. अच्छा जी. अब हमने क्या करना है? So I is equal to 1, ठीक है। अच्छा, और यानी हम वी आर टेकिंग स्टार्ट फ्रॉम द फर्स्ट एलिमेंट इन द इंडेक्स। नाउ व्हाट डू वी नीड टू डू, वी हैव टू चेक कि ये जो पहला एलिमेंट है क्या ये वो रिक्वायर्ड एलिमेंट है या नहीं, ठीक है, क्या ये वो रिक्वायर्ड एलिमेंट है या नहीं। अच्छा, इसमें एक और चीज़ भी है कि वी शुड बी डूइंग दिस होल थिंग इफ द लिस्ट इज नॉन एम्प्टी, ठीक है, इफ द लिस्ट इज नॉन एम्प्टी। सो इफ द लिस्ट इज एम्प्टी, if the list is empty, so that means कि we don't have anything in the list, so हम फिर क्या करेंगे, so we are going to return false, we are going to return false अगर list empty है। अगर list empty नहीं है तो फिर हमने ये वाला काम करना है। कौन सा वाला काम करना है, then we have to start from the first position and then we have to check each and every element, और हमने पोजीशन नंबर के तक अपने आप को पहुंचाना है, ठीक है। सो वाइल, वो हम करेंगे यूजिंग अ लूप। सो यू कैन से वाइल आई इज नॉट इक्वल टू के, जब तक आई के बराबर नहीं है, ठीक है, वाइल आई इज नॉट इक्वल टू के, ठीक है। अच्छा जी, वाइल आई इज नॉट इक्वल टू के, तो हमने क्या करना है, इसको हम लिख लेते हैं, देन वील मेक सम चेंजेस। सो इफ आई इज इक्वल टू के तो फिर तो बड़ा आसान है, ठीक है। बट इफ आई इज नॉट इक्वल टू के, तो बेसिकली वी हैव टू मूव टू द नेक्स्ट नोड, ठीक है। तो हमने पहले ये काम करना है, करंट इज इक्वल टू करंट एरो नेक्स्ट नोड एंड वी हैव टू इंक्रीमेंट आई, ठीक है, वी हैव टू इंक्रीमेंट आई। तो से फॉर एग्जांपल हमें कहा जाता है कि भाई आप थर्ड जो एलिमेंट है या फोर्थ जो एलिमेंट है उसको एक्सेस करें, फोर्थ एलिमेंट से के इज इक्वल टू 4। सो व्हाट विल हैपन, आप अरे के फर्स्ट एलिमेंट से स्टार्ट करते हैं, वी अज्यूम के अरे एम्प्टी नहीं है, ठीक है। इफ अरे इज नॉट एम्प्टी विल कम टू द एल्स पोर्शन एंड देन विल एंटर दिस लूप। अब आई जो है वो 1 है एंड के इज 4, सो 1 इज नॉट इक्वल टू 4, तो क्या होगा, हम पहले नोड से मूव करेंगे टू द सेकंड नोड एंड विल इंक्रीमेंट आई, ठीक है। नाउ आई इज 2, 2 इज नॉट इक्वल टू 4, तो हम सेकंड नोड से थर्ड नोड पे जाएंगे एंड वील इंक्रीमेंट आई। नाउ आई इज 3, 3 इज नॉट इक्वल टू 4, हम थर्ड नोड से फोर्थ पे जाएंगे और आई को इंक्रीमेंट कर देंगे, ठीक है। नाउ आई इज इक्वल टू 4 एंड 4 इज इक्वल टू के, सो आई और के दोनों बराबर हो गए, ठीक है, 4 इज इक्वल टू 4, तो हम इस लूप से बाहर निकल जाएंगे, हम इस लूप से बाहर निकल जाएंगे। अच्छा, इसका मतलब ये है कि ये जो करंट, अच्छा, इस लूप से हम बाहर निकल जाएंगे, इसका मतलब ये है कि हमारा ये जो करंट नोड है, क्या इसका मतलब ये है या नहीं। अच्छा, लेट्स सी कि हमारा जो करंट नोड है, वी नीड टू टेस्ट रन इट हियर। सो से फॉर एग्जांपल वी हैव टू एक्सेस दिस एलिमेंट, थर्ड एलिमेंट जो है, ठीक है। सो हम इस फंक्शन को कॉल करते हैं विद के इज इक्वल टू 3, हम इसको कॉल करते हैं। सो कैसे ये प्रोग्राम रन होगा, सो इनिशियली हम कहते हैं करंट इज इक्वल टू फर्स्ट एंड आई इज इक्वल टू 1, दैट इज व्हाट हैपेंस आउटसाइड दिस लूप, ठीक है। सो करंट इज इक्वल टू फर्स्ट एंड आई इज इक्वल टू 1, इट इज़ नॉट एम्प्टी, सो हम यहाँ पे आ जाते हैं। सो आई इज नॉट इक्वल टू के, आई 1 है एंड 1 इज नॉट इक्वल टू 3, 1 इज नॉट इक्वल टू 3, सो हम क्या करते हैं, वी मूव फ्रॉम द करंट नोड टू द नेक्स्ट नोड, हम यहाँ से यहाँ जंप लगा लेते हैं। सो करंट इज इक्वल टू करंट एरो नेक्स्ट, दैट इज व्हाट वी डू एंड वी इंक्रीमेंट आई, आई बिकम्स 2, ठीक है, आई बिकम्स 2। नाउ वी चेक 2 अगेन, 2 इज नॉट इक्वल टू 3, so this is true, we come here, we say current is equal to current error next, हम थर्ड नोड पे जंप लगा लेते हैं and we make I is equal to 3, now 3 is equal to k, it is not equal to, this condition becomes false and we get out of the loop, ठीक है, we get out of the loop, ठीक है। अच्छा, अब इसका हम यहाँ इस नोड पे मौजूद हैं और लूप से बाहर हैं, ठीक है। सो यहाँ पहुँच के अब हम इसका डेटा एक्सेस करके उसको स्टोर कर लेंगे इन द वेरिएबल x। सो ये जो हमें आर्गुमेंट मिला है ये वाला, इसमें हमने इस डेटा की वैल्यू स्टोर करनी है। तो x वुड बी इक्वल टू करंट एरो डेटा, ठीक है, एंड वी वुड से रिटर्न ट्रू and we could find that element, ठीक है, we could find that element, so this would work fine। इसमें एक कंडीशन लगानी है, ठीक है। वो कंडीशन क्या है? वो कंडीशन ये है कि हमारे पास, यानी when we say current is equal to current arrow next, ठीक है, सो ऐसा भी हो सकता है कि करंट एरो नेक्स्ट जो है वो हमारे पास नल हो, ज़ीरो हो। तो अगर वो नल होगा तो नेक्स्ट टाइम व्हेन दिस लूप रन्स, ठीक है, नेक्स्ट टाइम व्हेन दिस लूप रन्स, फिर ये कोड जो है वो ठीक काम नहीं करेगा, क्योंकि नेक्स्ट टाइम अगर हम उसे कहेंगे ना कि करंट इज इक्वल टू current arrow next, so since last time, and for example if we get to the end of this list, ठीक है, if we get to the end of this list, तो और k जो है वो हमारे पास ऐसी वैल्यू हो कि वो k लिस्ट के साइज से बड़ी हो, तो we'll get to the end of the list and we won't be able to find the kth element, ठीक है, क्योंकि इसके बाद there are no more nodes, and if you try to access these nodes, so you'll get an error, this program is going to crash, ठीक है। तो उसमें दो काम हम कर सकते हैं, one is if is empty, और यहाँ पे एक और कंडीशन लगा लें and, ठीक है, या अगर लिस्ट empty हो या k is greater than the list size, अगर k लिस्ट साइज से बढ़ के हो, ठीक है, तो देन रिटर्न फॉल्स। बट इफ दैट इज नॉट द केस, ठीक है, ना एम्प्टी हो और ना लिस्ट के जो है वो लिस्ट साइज से बढ़ के हो, यानी अगर आपकी लिस्ट में 10 एलिमेंट्स हैं और आप कह रहे हैं कि मुझे 15th एलिमेंट रिटर्न करके दो, दिस इज रॉन्ग, योर प्रोग्राम शुड फ्लैग इट कि भाई ऐसा नहीं हो सकता, ठीक है। So these two conditions would ensure कि you will not run into that situation, ठीक है। और बाकी ये जो कोड है it will run fine if the list is not empty and if k is less than list size, so you would be able to find this element, ठीक है। अच्छा, so this is what it does this is the find method। the next method is the search method, ठीक है। let's see कि search method में क्या होता है। अच्छा, now what do we do in search method? search method क्या करता है? search method करता है x को locate करता है and returns its position if found, ठीक है। so what it does not know the position, it only gets a value कि इस value को मालूम करो, and फिर उस वैल्यू पे जब ये पहुंचता है तो उसकी पोजीशन रिटर्न करता है, ठीक है। सो दिस इज आल्सो easy to implement। so what you need to do is say look at this list again, इसको तो हम दूसरे पर्पस के लिए इस्तेमाल किया लेकिन still, so this is a list, say for example we need to search for 30, say for example, so what we'll do is we'll start from the first node and we'll visit that node and we'll check if this value is equal to the value that we are looking for. If it is not, we'll move to the next node, we'll check if the value we are looking for is stored in this node or not. If it is not, then we'll move to the next node, ठीक है। और हर नोड से नेक्स्ट नोड पे जाते हुए we'll increment some index variable ताकि हमें पता लगे कि इस वक्त हम किस पोजीशन पे हैं, ठीक है। and once we find that value we'll return that index variable की जो value है उसको हम return कर लेंगे। so how are we going to do that? How are we going to search for an element? So this is how we are going to do it. Again, as I said, okay, this is going to be your most important piece of code in this class. So let us copy this code and bring it here. Actually, so what we are going to do is we are going to, let me get rid of this code. So what does this function need to do? It needs to find this value, okay, whether this value is stored in the list or not, and it needs to return the position at which this value is stored in the list. That is what it needs to do. Okay? So we need to have this variable current because we have to visit potentially all the elements, all the nodes in the list, and we have to look for this value x. Okay? And we also need to keep track of the index. We also need to keep track of the index. Okay? So for that we need to declare a variable I, since I is equal to 1. Okay? So when we say current is equal to first, so we are at the first position, I is equal to 1. We are at the first position in the list. Now, while current is not equal to 0, okay, so we should be doing it. Okay, but इसके अलावा we should also do something. Okay, while current is not equal to 0, and we should also do something. What is that we should do? So this loop will basically allow us to visit each and every node. Okay? This loop will allow us to visit each and every node starting from the first node, and it will allow us to move to the last node, the very last node. Okay? Now when we visit each node, we need to check its value. Okay? We need to check its value. So we need to make this check. Okay? Mm, if current arrow data is equal to x, okay, if current arrow data is equal to x, then what? Okay, if that is the case, then we need to do something. And what is that? We just need to return the value of x. We need to return the value of x, and once we return the value of x, we'll be out of this function. Okay, if that is not the case, we need to move to the next node, and we need to increment the index I. Okay, we need to increment the index I. Acha. And we are not going to return x. In fact, we are going to return the index at which we found this value. So imagine like this function is being called for the very first time, and it is provided, say, consider this singly linked list, and say this function has been called with the value 80 in x. Okay, so we want to search for 80 in this linked list. So what will happen? So this function is going to be called, and the current pointer will first store the address of the first node. So it will basically point to the first node, and the integer I will store the variable 1. Why? Because right now current has the address of the first node. Now inside this loop, what are we checking? We need to make sure that current is not equal to null, like it is not a dummy, it is not a null node, it is an actual node that exists with some data and pointer to a next node as well. So we are here at the first node, so we need to be sure that current is not equal to null. That is the condition for this loop. We check whether the data stored in this node is equal to x or not, the one that we are looking for. So this node has 20 and we are looking for 80. So this condition would be false. So this statement is not going to get executed. What we are going to do is we are going to jump to the next node and increment the index. So we are going to jump to this node. Now this node is also the address of this node is not equal to 0. So this condition is true. We are going to enter here. We are going to compare the data stored in this node with the value that we are searching for. So it has 10 and we are searching for 80. So that means this condition is not true. So we are going to get here. So we are going to move to the next node and increment I. So I would be 3 and we would be at this node with 30. We are going to compare 30 with the value that we are looking for, which is 80. So they are not equal. So what we are going to do, we are going to move to the next node and increment the index I. So we are going to jump to this node and increment I. I now is 4 and we are at this node. Now this node has 80 and we are looking for 80. Okay. So this condition would be true. This condition would be true. And we are going to return the value of I, which is 4. And we are going to get out of this function. So this is how we search for this value. Okay. Okay, Ji. I hope search is also clear. Search is also clear. Now let's get here and try understanding the delete operation. The delete is a little tricky. What does the delete function say? The delete function say delete the fourth element from the singly linked list. So this is say the fourth element. Okay? This is say the fourth element. So first of all, we need to be sure whether we have a fourth element or not. Whether we have a fourth element or not. So in order to be sure, you can first call the find function. You can first call the find function, and if this element exists, the find function will return true. Okay. So once it returns true, then you can like very confidently go and get rid of this particular element. Okay. How do you get rid of this element? So if you want to get rid of, say, the fourth element, if you want to delete the fourth element, so what you need to do is you need to, like, when this element is removed, when 80 or this node is removed, so what would be the new situation? After we get rid of this thing, okay, so then this node should point to this node. Okay, so we should have this connection, the one that is shown in the form of dotted arrow. We should establish this connection. How are we going to establish this connection? So this link or this variable should point to this node instead of this node. This pointer should hold the address of this node instead of this node. Where is the address of this node? The address of this node is here, in the node which we are going to delete. So we need to store this address somewhere. Okay? We need to store this address somewhere. Okay? So we need to store this address somewhere, the value of this pointer somewhere, so that like when we delete it, so we don't lose that value. Or before deleting it, we need to copy the value that is stored here to this place, so that it can point to the next node once this one is deleted. Okay. So this is basically what's going to happen. If we want to delete the fourth node or fourth element, we need to locate the third and fourth both nodes. Okay? The fourth node, the one that is going to be deleted, and the node before that, which is going to point to the node after this one. So we need to get hold of both these nodes. Okay? We need to get there. What we need to do is we need to link the third node, this node, to the fifth one. The fourth one will be deleted. We need to create this link, and once this link has been created, then we need to delete the fourth node and free up the memory so that that memory is available for reuse. Okay, this is how delete is going to work. This is how delete is going to work. So let's write the code for deleting a node. Right now we don't have a single node in the linked list, but we are going to try to delete the node. ठीक है? अच्छा, तो delete function क्या करेगा? Delete function would delete the node at the kth position, and it would return the value that it deleted in this variable. ठीक है? That is what it's going to do. अच्छा जी. So first of all, we need to be sure कि जिस node को हम delete कर रहे हैं वो exist भी करता है या नहीं. ठीक है? So how can we be sure? We have to call the find function. We have to call the find function. ठीक है? अच्छा जी. So let us call the find function. So if we can find this node, if find, ठीक है? So k find को k पास कर देते हैं और x पास कर देते हैं, दोनों पास कर देते हैं. There is no harm in doing that. ठीक है? If we can find this node, So if this node exists, it would return a true value. ठीक है? So you can compare it explicitly. If find this returns a true value, or you can simply write if find. ठीक है? So that means find जो है ना, this function returns a boolean value. ठीक है? Which is either true or false. So if it is true, so फिर हमने क्या करना है? फिर हमने deletion वाला काम करना है. ठीक है? और इफ़ इट इज़ फॉल्स, तो फिर क्या करना है? फिर तो डिलीशन नहीं हो सकती. लेकिन इन एनी केस वी विल रिटर्न द लिंक लिस्ट, उसका एड्रेस हम रिटर्न करते हैं. सो रिटर्न दिस पॉइंटर. ठीक है? सो उसको हम रिटर्न कर रहे हैं. अच्छा, सो इफ़ वी कैन फाइंड दिस नोड एट द kth पोजीशन, दैट मीन्स कि ये नोड एग्जिस्ट करता है. सो वी कैन फाइंड एंड डिलीट इट. ठीक है? वी कैन फाइंड एंड डिलीट इट. सो लेट्स डू दैट. सो अगर आपने kth नोड को डिलीट करना है, चौथे नोड को डिलीट करना है, यहाँ हमने देखा. सो यू नीड टू लोकेट थर्ड एंड फोर्थ नोड बोथ. उससे पिछला नोड भी आपको चाहिए. ठीक है? तो लेट्स गो एंड फाइंड देयर, गो एंड फाइंड दैट. ठीक है? फाइंड बोथ द नोड्स. सो अगेन हमारा जो करंट पॉइंटर है वो हमारे काम आएगा. ठीक है? करंट, एंड लेट अस इनिशियलाइज इट टू फर्स्ट. सिमिलरली हमारा इंडेक्स जो है वो भी हमारे काम आएगा. इंट आई इज इक्वल टू 1. ठीक है? अच्छा, तो हमने क्या करना है? हमने सिंपल ये काम करना है कि हमने k माइनस फर्स्ट नोड तक पहुंचना है. चौथा नोड हमने डिलीट करना है, तो तीसरे तक पहुंचना है. तीसरे तक पहुंच गए तो चौथा और ये तीसरा दोनों हमारे हाथ में होंगे. ठीक है? वो हम कैसे करेंगे? तो फर्स्ट ऑफ ऑल वी नीड टू मेक श्योर कि दिस नोड एग्जिस्ट. वो हमें फाइंड बता देगा. जब फाइंड कहता है कि हाँ जी एग्जिस्ट करता है, सो वी नीड टू हैव द सिंपल लूप व्हाइल करंट इज नॉट इक्वल टू नल. तो हमने सिंपल सा काम करना है कि वी हैव टू मूव टू द नेक्स्ट नोड. ठीक है? करंट एरो, करंट इज इक्वल टू, सॉरी, करंट इज इक्वल टू करंट एरो नेक्स्ट. ठीक है? अच्छा, और सिर्फ ये कंडीशन काफ़ी नहीं है. while current is not equal to 0 and current is, sorry, and I is less than k, I is less than k. तो हमने नेक्स्ट मूव नोड पे मूव करते जाना है और i को इंक्रीमेंट करते जाना है. ठीक है? सो ये लूप क्या करेगा? ये लूप हमें, अगर हमने kth नोड को डिलीट करना है, सो इट विल गेट अस टू k माइनस फर्स्ट नोड. अगर हमने तीसरे नोड को डिलीट करना है तो ये दूसरे नोड तक पहुंचा देगा. अगर 10वें नोड को डिलीट करना है तो ये 8वें नोड तक हमें पहुंचा देगा. ठीक है? क्योंकि हम i लेस देन k, एज सुन एज i बिकम्स इक्वल टू k, सो दिस, हम इस लूप से बाहर आ जाएंगे. वंस हम इस लूप से बाहर आ जाते हैं, तो इसका क्या मतलब है कि अगर हम चौथे नोड को डिलीट करना चाह रहे हैं, तो इस वक्त हम तीसरे नोड पे हैं. दैट मीन्स कि करंट जो हमारा नोड है, इट इज़ एट नोड नंबर 3 एंड वी हैव टू डिलीट नोड नंबर 4. ठीक है? लेट अस डिक्लेयर अनदर वेरिएबल नोड डिलीट मी. तो ये वो नोड है जिसको हमने डिलीट करना है. ठीक है? सो डिलीट मी कौन सा नोड है? डिलीट मी इज करंट एरो नेक्स्ट. ठीक है? दोबारा से समझें. ये इंडेक्स i इज इक्वल टू 1. ठीक है? हम लिस्ट को एक्सेस कर रहे हैं. इस लिस्ट में से हमने kth एलिमेंट को डिलीट करना है. लेट अस अस्यूम कि k इज इक्वल टू 4. हमने चौथे एलिमेंट को डिलीट करना है. सो वी हैव टू स्टार्ट फ्रॉम द फर्स्ट एलिमेंट एंड वी हैव टू रीच टू द फोर्थ एलिमेंट. ठीक है? सो फर्स्ट ऑफ ऑल वी हैव टू मेक श्योर कि चौथा एलिमेंट एग्जिस्ट करता है. उसके लिए ऑलरेडी हमने एक फंक्शन लिखा है फाइंड. सो दैट विल, अगर ये एलिमेंट एग्जिस्ट करता हुआ तो फाइंड वुड रिटर्न अ ट्रू वैल्यू, और ये कंडीशन ट्रू हो जाएगी एंड वील एंटर दिस लूप. ठीक है? वील एंटर दिस ब्लॉक इफ कंडीशन में हम एंटर हो जाएंगे. अब यहाँ हम ये लूप यूज कर रहे हैं टू गेट टू द थर्ड एलिमेंट. हमने चौथे को डिलीट करना है, तीसरे तक हम पहुंचना चाहते हैं. वो कैसे हम पहुंचेंगे? सो हम पहले काम ये कर रहे हैं कि वी स्टार्ट फ्रॉम द फर्स्ट एलिमेंट. करंट इज इक्वल टू फर्स्ट हमने कर दिया. हम कह रहे हैं कि इफ करंट इज नॉट इक्वल टू 0 एंड इफ i इज लेस देन k, इंडेक्स फिलहाल i 1 है, k जो है वो 4 है. तो अगर i 4 से कम है और जिस नोड पे हम हैं वो इट इज़ अ वैलिड नोड, तो हम क्या करते हैं, वी मूव टू द नेक्स्ट नोड एंड वी इंक्रीमेंट आई। सो इस अरे को देखें, इस लिंक लिस्ट को देखें, सॉरी। सो वी स्टार्ट फ्रॉम द फर्स्ट नोड, ठीक है। द फर्स्ट नोड, ये जो करंट इसमें एड्रेस है, इट इज़ नॉट इक्वल टू ज़ीरो, एंड आई जो है वो भी 4 से कम है, इनिशियली इट इज़ 1। सो हम क्या करते हैं, वी से करंट इज इक्वल टू करंट एरो नेक्स्ट, सो वी जंप टू द नेक्स्ट नोड एंड वी इंक्रीमेंट आई। नाउ आई इज़ 2, वी आर एट द सेकेंड नोड, और करंट स्टोर्स इट्स एड्रेस। सो देन लूप की कंडीशन हम चेक करते हैं कि करंट इज़ नॉट इक्वल टू ज़ीरो, सो इट इज़ नॉट इक्वल टू ज़ीरो, ये एक वैलिड नोड है। And the next condition that we are checking is I less than k, so I2 है which is less than 4, ठीक है। So this is true, so we enter the while loop, वहाँ पे हम क्या करते हैं, current is equal to current arrow next, we jump to the next loop, next node, and we increment I. So now I is 3, and this node current is not equal to 0, ठीक है। तो अब हम क्या कर रहे हैं, वापस हम यहाँ पे आए, तो अब I क्या हो जाता है, 3 है, एंड 3 इज लेस देन 4, ठीक है। 3 इज लेस देन 4, दिस कंडीशन इज ट्रू। सो व्हाट डू, वी से करंट इज इक्वल टू करंट एरो नेक्स्ट, सो वील जंप टू द फोर्थ नोड, ठीक है। दिस इज, वी डोंट वांट दैट, वी डोंट वांट टू जंप हियर, वी वांट टू स्टे हियर। तो इसका मतलब ये है कि हमें इस लूप में थोड़ी सी चेंज करनी होगी इस कंडीशन में। सो व्हाइल आई इज लेस देन k पे 3 पे वो ट्रू होगा, वी वांट टू स्टॉप एट दिस, सो व्हाइल i इज लेस देन k माइनस 1, ठीक है। i इज लेस देन k माइनस 1, तो देन हम 3 पे स्टॉप कर सकेंगे, ठीक है। अगर 3 पे स्टॉप ना किया तो वो चौथे पे यहाँ जंप लगा लेगा, और i की वैल्यू भी 4 हो जाएगी। सो वी वांट टू स्टॉप एट द थर्ड वन, हम यहाँ इस नोड पे रुकना चाहते हैं। इस नोड पे रुकने के लिए I should be equal to 3, ठीक है। now sorry, I should be equal to, yes, 3, I को 3 ही रहना चाहिए। तो जब हम इस लूप में फॉर एग्जांपल I इज इक्वल टू 2 के साथ आएंगे, सो 2 इज़ लेस देन 4 माइनस 1, 3, कंडीशन ट्रू है। तो 2 ये वाला है, तो यहाँ से जब हम जंप लगाएंगे, दिस इज़ द थर्ड एलिमेंट, ठीक है। और okay, maybe this is confusing, so let us do it again, ठीक है, with this new condition जो हमने लगाई है। so imagine कि हम इस function को कॉल करते हैं for k is equal to 4, and also assume कि this element exists, so we are here, so we start from the first element in the array and I is equal to 1, ठीक है। so पहली condition जो हम चेक करते हैं कि current 0 के बराबर ना हो, यानी it should be a valid node, and I which is 1 should be less than k minus 1, k minus 1 is 3, so I should be less than 3, so I is less than 3 and this is a valid node, so we jump here। जब हम यहाँ jump करते हैं तो हम I को increment कर देते हैं, now I is 2 which is less than 3 and this is a valid node, so we jump here and then we increment I, so now I becomes 3 and 3 is not less than 3, 3 is equal to 3, so that condition becomes false and we get out of the loop। लूप से हम बाहर आ जाते हैं, बट हम थर्ड नोड पे हैं और हम फोर्थ को डिलीट करना चाहते हैं, यानी वी आर एट k माइनस फर्स्ट नोड एंड वी वांट टू डिलीट द kth नोड, सो वी आर एट द राइट पोजीशन, यहाँ पे हम बिल्कुल ठीक पोजीशन पे हैं। सो वी वांट टू डिलीट द kth नोड एंड वी आर एट द करंट बेसिकली होल्ड्स द एड्रेस ऑफ k माइनस फर्स्ट नोड, सो जिस नोड को हम डिलीट करने जा रहे हैं उस नोड का एड्रेस हम इस वेरिएबल डिलीट मी में स्टोर कर लेते हैं, ठीक है। दिस इज द नोड दैट वी आर गोइंग टू डिलीट एंड इट्स एड्रेस इज इन करंट एरो नेक्स्ट, ठीक है। अच्छा, तो किसी भी नोड को डिलीट करने के लिए हम पहले क्या करते हैं, लोकेट द थर्ड एंड फोर्थ नोड्स, locate the k minus first and kth nodes, so we have located that, this is the first thing that we do। so in this loop, this is what we did, we located the k minus first and kth node। k minus first node का एड्रेस करंट में पड़ा हुआ और kth node का एड्रेस करंट एरो नेक्स्ट में पड़ा हुआ, ठीक है। link the third node to the fifth, but before that we need to store the address of the node that we want to delete। so मैं उसका एड्रेस यहाँ पे स्टोर करूँ, इस नोड को, दिस इज द kth नोड जिसको हमने डिलीट करना है, ठीक है। इसका एड्रेस मैंने स्टोर कर लिया, इसका एड्रेस यहाँ पे करंट एरो नेक्स्ट में था, ये मैंने स्टोर कर लिया। अब मैं k माइनस फर्स्ट नोड को k प्लस फर्स्ट नोड से लिंक कर रहा हूँ, यानी थर्ड नोड को फिफ्थ नोड से लिंक कर रहा हूँ, फोर्थ को हमने डिलीट करना है, ठीक है। फोर्थ को हमने डिलीट करना है, इसका एड्रेस मैंने डिलीट मी पॉइंटर में स्टोर कर लिया, और इसका एड्रेस मेरे पास करंट पॉइंटर में है। इसको मैंने लिंक करना है विद दिस नोड। इसका एड्रेस कहाँ पे है? जिस नोड को मैं डिलीट करने जा रहा हूँ उसके नेक्स्ट में इसका एड्रेस पड़ा हुआ है। सो वी कैन क्रिएट दैट लिंक। वी कैन से करंट एरो नेक्स्ट, ठीक है, करंट एरो नेक्स्ट is equal to the node that we are going to delete, ठीक है, उसका जो नेक्स्ट नोड है। तो ये हमने वो लिंक क्रिएट कर लिया, ठीक है। इस नोड को हम डिलीट करने जा रहे हैं। इस नोड के नेक्स्ट पॉइंटर में इस नोड का फिफ्थ नोड का एड्रेस है, इसको मैंने कॉपी कर लिया इनटू दिस नेक्स्ट पॉइंटर, ठीक है। तो ये वाला लिंक क्रिएट हो गया, और ये जो नोड है इसका एड्रेस मेरे पास मौजूद है इन द डिलीट मी पॉइंटर, सो आई कैन डिलीट इट स्ट्रेट अवे, ठीक है। आई हैव क्रिएटेड दिस लिंक एंड नाउ आई एम रेडी टू डिलीट इट, ठीक है। सो द फर्स्ट थिंग दैट यू नीड टू डू इज if you have to delete the kth node, so you need to locate the k minus first and kth node. That is the first thing that you need to do. Then you need to store the address of the kth node, इसका एड्रेस स्टोर कर लें। Then you need to link the k minus first node with the k plus first node, ठीक है। This is how you do it. This is how you do it. Once you have done that, then you can delete the node that you have to delete, ठीक है। Then you can delete the node that you have to delete. But उससे पहले हमने वो जो एड्रेस है, सॉरी वो जो डेटा है वो x में रिटर्न करना है। So we can say x is equal to, इस नोड को हम डिलीट करने जा रहे हैं, delete me arrow data. So this has been copied into x and now we can delete it. Delete, use the delete operator, delete me, ठीक है। So this node would be deleted. Once we are done with all this, so we can return pointer to the linked list that we have, ठीक है। So we can return this pointer and I guess we are good to go, ठीक है। This code would work fine. अच्छा, सारे काम हमने कर लिए, but we haven't inserted even a single node into the linked list. So let's do that. And the insert is also similar to delete, ठीक है। तो इसको हम we can use this code, ठीक है, for insertion as well, ठीक है। हम थोड़ा सा नाम चेंज करने की ज़रूरत होगी। So let us use this code for insertion as well. अच्छा, let's first understand कि insertion में होता क्या है। So this is the insert operation. So what happens in the insert operation? To insert an element following the kth, so kth node के बाद हमने नया element insert करना है, ठीक है। So the insert function specifies two things. One, k, कि इस node के बाद आपने इसको insert करना है, ठीक है। अच्छा, तो कैसे insert करेंगे? This is the node, ठीक है। अच्छा, k can be k can have different values. It can be 0, it can be greater than 0, ठीक है। So दोनों cases में, if it is 0, that means you have to insert it at the beginning of the linked list. If it is a non-zero value, that means you have to insert it somewhere in between, ठीक है। अच्छा, so अगर 0 at the beginning of the list आपने एक entry डालनी हो तो फिर क्या करेंगे? So जो say this is the new node that you want to insert at the beginning of the list. So what it needs to do is this node needs to point to the first node in the list, ठीक है, क्योंकि this would become the first node and the first node would become the second node. समझ आ रही है? This is the existing. Let me go to the slideshow. We are looking at two possibilities for the insert operation. One, when the position that you want to insert this node is 0, आप यूज़र कहेगा जी 0th node के बाद, यानी you want this new node to be the first node. If this is what you want, so this is say different than this case where we want to insert the node at after after the kth node where k is greater than 0. ठीक है, so these two cases are different. कैसे different हैं? यहाँ पे देखें, यहाँ पे this is the new node that you want to insert and you want to insert it after the 0th position. That means you want it to be at the first position. You want it to be at index 1. That is what you want. Right now this is index 1 and its address is stored in first. तो जब ये नोड इस लिस्ट में आ जाएगा, so this node would become first. और ये जो करंट जो फर्स्ट नोड है, this would become the second. It would be after this node. ठीक है, this would become the second node. तो ये काम आप कर सकते हैं. तो कैसे करेंगे? ये जो नया नोड आपने क्रिएट किया है, इसके नेक्स्ट में आपने मौजूदा फर्स्ट नोड का एड्रेस स्टोर कर देना है. तो ये लिंक क्रिएट हो जाएगा. ठीक है, एंड इस नोड का एड्रेस इज इन दिस फर्स्ट पॉइंटर. So you have to set the next attribute of this node to first. So this link would be created. And then you have to change first. इसकी value change कर देंगे. It should point to the new node, not to this particular node. ये जो node है इसको नहीं point करना. So you have to make it point to this node. तो ये link create हो जाएगा और ये link खत्म हो जाएगा. So you would be able to insert a new node at the very beginning of the list. ठीक है, at the very beginning of the list. अगर आप चाहते हैं कि you want to insert a node at any अच्छा at any other position k which is non-zero, so उसके लिए फिर क्या करना होगा? So you have to get to the kth position. First you need to get to the kth position. Once you are there, so ये जो kth node है, it should point to the new node, and the new node should point to the node after the kth node. ठीक है, kth node के बाद जो node है वो इसके बाद वाला हो जाएगा. इन दोनों नोड्स के बीच इसने आना है. सो फर्स्ट ऑफ ऑल ये जो न्यू नोड है इसका नेक्स्ट आपने सेट करना है टू दिस नोड. ठीक है, इट शुड पॉइंट, फर्स्ट आपने ये लिंक क्रिएट करना है. ठीक है, ये लिंक क्रिएट करना है. ये लिंक कैसे क्रिएट होगा? सो इसका ये नया नोड है, इसका जो नेक्स्ट जो एट्रीब्यूट है उसमें आपने इस नोड का एड्रेस स्टोर करना है और इस नोड का एड्रेस आपके पास मौजूद है kth नोड के नेक्स्ट एट्रीब्यूट में. So first of all you have to say new node arrow next is equal to this kth node arrow next. So this link would be created. Then the kth node should point to the new node. ठीक है, so we would say कि kth node arrow next is equal to new node. So this link would be created and this link would be severed. So इस तरीके से ये नया नोड आप insert कर सकेंगे. ठीक है, so I hope this is clear. Let us code this operation. अच्छा जी, एक अगर आपको याद हो, मैंने आपसे कहा था कि whenever we delete a node, so we will modify the list size. ठीक है, तो जब भी आप नोड डिलीट करेंगे so we will modify the list size, क्योंकि नोड हमने एक डिलीट कर दिया है. so this would be minus decrement list size. ठीक है, तो यहाँ पे हम डेक्रीमेंट करेंगे लिस्ट साइज को. अच्छा जी, नाउ लेट अस इम्प्लीमेंट द इंसर्ट फंक्शन. कहाँ गया जी इंसर्ट? सर्च डिलीट, अच्छा दिस इज इंसर्ट. ठीक है, उसमें हमने वो कोड कॉपी कर दिया था. अच्छा, लेट अस कॉल दिस एज न्यू नोड. ठीक है, लेट अस कॉल दिस एज न्यू नोड. अच्छा, न्यू नोड का जो डेटा है ना वो हमारे पास इस वेरिएबल में आ रहा है x में. सो द डेटा पार्ट ऑफ इट इज कमिंग हियर. सो वी विल बेसिकली क्रिएट अ नोड और उसके डेटा को ये वैल्यू हम असाइन करेंगे. ठीक है, सो दैट विल बी अ न्यू नोड. अच्छा, शुड वी क्रिएट इट नाउ एट द वेरी बिगिनिंग? नो, वी शुड नॉट डू दैट. ठीक है, वाई? बिकॉज हमने पहले वेरीफाई करना है कि ये दिस kth पोजीशन इज अ वैलिड पोजीशन. ठीक है, अच्छा जी, so let's do that. ठीक है, let us get rid of this code, write it again. अच्छा, so हमारे पास सबसे पहले जो हमने काम करना है वो वेरीफाई करना है the values of k. ठीक है, या if we have those two condition, if k is equal to 0, if k is equal to 0, that means we are going to insert the new node at the very beginning of the list. तो वो हम कैसे करेंगे, ठीक है, तो उसकी ये सूरत हाल है. So we'll create the new node. First of all, let us create the new node. So new node is equal to new node, ठीक है, and let us assign it this data. New node arrow data is equal to x, ठीक है. We assigned it this data. New node is equal to new node, and then new node arrow data is equal to x. So we have the new node. अच्छा, फिर ये जो नया नोड है इसने आना है एट द बिगिनिंग ऑफ द अरे, ठीक है. सो जो एग्जिस्टिंग हमारा पहला नोड है दैट विल बिकम द सेकंड नोड, और उसका एड्रेस हमने स्टोर करना है इन द नेक्स्ट पॉइंटर ऑफ द new node. So new node arrow next would be equal to first, and first would be then the new node. हमारा जो नया first होगा of the linked list that would be this new node, ठीक है, and we should increment the size. अच्छा, ये जो possibility this would help us initially जब when there are no items in the linked list, so we should be able to insert new items. अच्छा, I को नहीं increment करना, sorry, list size को increment करना है, ठीक है, list size को increment करना. So this is this is when we want to insert a new node at the beginning of the list, or when the list is empty and we want to insert new nodes into it. So this possibility will help us, ठीक है. The second condition is else if k is greater than 0 and k is less than list size. It should be less than list size as well, ठीक है, or less than or equal to list size. Less than or equal to be, there is no problem. Like we can insert a new node after the last element in the linked list. That we can also do, okay. So k, if k is greater than 0 and k is less than or equal to list size, then what should we do? Okay, the first thing that we need to do is we need to get to the kth element. We need to get to the kth element. How can we do that? So we have the current pointer, and using the current pointer we will get to the kth element, okay. So let's do that. So while current is not equal to 0, okay, what are we going to do? We are going to do this. Current is equal to current arrow next, current arrow next. Acha. And plus plus I, increment I. So not only are we going to check the value of current, but we are also going to keep a check on the value of index I, okay. So current should also be equal to not 0, and the index I, it should be less than k. It should be less than k. It should be less than k. So when it is less than k, so ultimately we are going to reach the last element, the kth element, okay. So that you can verify. For example, k अगर हमारे पास 4 है, ठीक है, और I is equal to 1 है, तो ये कोड क्या करेगा, ठीक है. So say let us look at this array. So k 4 है और I हमारे पास 1 है और ये हमारा कोड है, ठीक है. This is our loop. So initially current is not equal to 0. Yes, it is not equal to 0, and I, which is 1, is less than 4. So we'll move here. I will become 2. 2 is less than 4. We'll move here. I becomes 3. 3 is less than 4. We move to the fourth node or kth node, ठीक है. एंड नाउ इट इज़ नॉट इक्वल टू, सो हम यहाँ से बाहर निकल जाएंगे. सो वील बी एट द kth नोड, और हमने नया नोड इंसर्ट करना है आफ्टर द kth नोड. ठीक है. सो इंसर्शन कैसे करनी है? इंसर्शन हमने ये जो नया नोड है इसका जो नेक्स्ट होगा दैट वुड बी kth नोड का जो नेक्स्ट है. सो पहले तो हम नया नोड क्रिएट करेंगे. सो आउट ऑफ दिस लूप विल बी एट द kth नोड. ठीक है. सो वी आर एट द kth नोड, वी आर एट द kth नोड. अब यहाँ पे हमने ये सारे ऑपरेशंस करने हैं. पहला ऑपरेशन क्या करना है? वी हैव टू क्रिएट द न्यू नोड. ठीक है. सो नया नोड हम यूँ क्रिएट करेंगे. अच्छा जी, नया नोड क्रिएट कर लिया, उसमें डेटा भी स्टोर कर लिया. अब नया नोड जो है इट वुड पॉइंट टू, यानी द नेक्स्ट नोड ऑफ दिस न्यू नोड वुड बी हमारा जो करंट नोड है kth नोड, उसका जो नेक्स्ट नोड है. सो करंट एरो नेक्स्ट. ठीक है. दैट वुड बी द नेक्स्ट नोड. सो करंटली वी आर हेयर, करंटली वी आर हेयर. नया नोड जो आएगा वो पॉइंट, उसके बाद वाला नोड ये वाला होगा, इसका एड्रेस करंट के नेक्स्ट में पड़ा हुआ है. सो न्यू नोड एरो नेक्स्ट इज इक्वल टू करंट एरो नेक्स्ट. सो ये वाला लिंक हम, यानी करंटली वी आर एट द kth नोड, नया नोड शुड पॉइंट टू द नोड आफ्टर द kth नोड, उसका एड्रेस पड़ा हुआ है इन द kth नोड करंट में. ठीक है. So new node arrow next is equal to current arrow next. So this link has been created. This one, this has been created. और फिर kth node का जो next है that should be the new node. So this link would be created and this link would be destroyed. So next would be कि current का जो next node है, current arrow next, that should be the new node. ठीक है. That should be the new node. Now all the links have been created. And increment list size. ठीक है. So I hope this code works, and we have to test it to see if it works or not. So let us test it. ठीक है. Include my classes. अच्छा जी. Now let us first create a singly linked list class. Singly linked list. Let us call it as SL. ठीक है. So let us find out the size of SL. ठीक है. Size of SL is equal to and SL dot length. ठीक है. So we need to get its length, and then end there. अच्छा, so it would be 0, empty. ठीक है. It would be 0 or empty. Then we can start inserting. We can say SL dot insert. ठीक है. SL dot insert. अच्छा, what do we need to insert? So we need to specify kth position and the data. ठीक है. अच्छा जी. So let us do it in a loop. ठीक है. Let me declare a variable int data. Initial value is 0. ठीक है. And let us, okay, so initial value is 0. Let us generate some value, or we don't need to generate random values, say. Let us do it simply. So let us insert some values in a loop. For int I is equal to 0, I less than 5 plus I. Okay. So what are we going to do here? We are going to insert new data at the very beginning of the list. Okay. So we are going to say k is equal to 0 पे आप data copy करें. ठीक है. Data की initial value यहाँ पे 0 है. Let us make it something like this. Data is equal to I multiplied by, sorry, I square plus 2. Okay. So this is data. Acha, so we are going to insert this data. Acha, we have not created the destructor. Now let us create the destructor as well. That is also important. So here, this is the destructor. So the destructor, it will destroy each node. ठीक है, starting from the very beginning, the first node, so it will visit each node and then destroy individual nodes. So how is it going to do it? So we are going to use the current pointer to visit each node. ठीक है, we'll set it to first. Current is equal to first, so we are going to start from the first node, and then while current is not equal to null, we are going to continue. ठीक है, and what are we going to continue with? So we need to keep we need to have a pointer to store the address of the node that we need to delete. Okay, अच्छा, तो वो कौन सा नोड होगा? Let us initialize it to first as well. So the first node is going to be deleted first. While current is not equal to null, so अब हमारे पास जो पहला नोड है ना, उसका एड्रेस दो जगहों पे है, एक delete me में है और एक current pointer में है. ठीक है, so you can say delete me, इस नोड को delete कर दें. ठीक है, या बिफोर डूइंग दैट थोड़ा सा सोच लें. अच्छा, क्या करना है हमने? सो दिस इज हाउ द डिस्ट्रक्टर वुड डू. सो डिस्ट्रक्टर वुड स्टार्ट हियर, पहला नोड, सो इट वुड जंप फ्रॉम दिस नोड टू दिस नोड, बट इट वुड कीप कॉपी द एड्रेस ऑफ दिस नोड. और जब ये यहाँ पे पहुँच जाएगा, यानी करंट में जब इसकी वैल्यू वो होगी, तो फिर ये इस नोड को डिलीट कर देगा. सो द फर्स्ट थिंग दैट वी नीड टू डू इज we need to say current is equal to current arrow next, यानी we need to move to the next node. उसका एड्रेस हमारे पास होना चाहिए. if we delete this node, तो वो एड्रेस हम लूज कर जाएंगे. ठीक है, then we need to delete this node. ठीक है, and then we need to say कि delete me is equal to current. अच्छा, अब इस कोड को हम एग्जीक्यूट करेंगे बारी बारी. So keep in mind this linked list. So let us start executing this code. So we enter this, destructor is executed, so current key value is set to the first, so current points to this node. ठीक है, और delete me also points to this node. ठीक है, अच्छा, अब क्या हो रहा है जी? अब ये हो रहा है कि हम कह रहे हैं while current is not equal to 0, so current is definitely not equal to 0. ठीक है, अच्छा, तो this condition is true, we enter the loop and here we say current is equal to current arrow next. so ये जो current हमारे पास पॉइंटर है, उसमें हम next जो एलिमेंट है उसका एड्रेस स्टोर कर लेते हैं. अब इसका एड्रेस हमारे पास कहाँ पे है? delete me पॉइंटर में, और इसका एड्रेस current पॉइंटर में. So now we can delete this node because इसमें जो information हमें चाहिए थी वो हमने सेव कर ली है in the current node. ठीक है, so we can delete this node. So we delete the delete me node. अच्छा, इस नोड को हमने डिलीट कर लिया. अब नेक्स्ट टाइम जो नोड डिलीट होगा ना, वो ये वाला नोड होगा जिसका एड्रेस करंट में पड़ा हुआ है. सो हम डिलीट मी में करंट, जो मौजूदा करंट है विच हैज़ द एड्रेस ऑफ दिस नोड, उसको हम स्टोर कर लेते हैं. दिस हैज़ टू बी डिलीटेड. ठीक है, अच्छा, देन वी करंट को हमने यहाँ पे करंट एरो नेक्स्ट भी सेट किया हुआ है. सो वी गेट बैक, वी चेक कि करंट नॉन ज़ीरो के बराबर है या नहीं. ठीक है, इफ़ करंट इज़ नॉट इक्वल टू ज़ीरो, विच इट इज़, ये ज़ीरो के बराबर नहीं है, सो व्हाट डू वी डू? हम करंट को सेट कर देते हैं. अच्छा, करंट एरो नेक्स्ट. ठीक है, करंट को हमने सेट कर दिया करंट एरो नेक्स्ट. ठीक है, सो करंट वुड देन पॉइंट टू 30, दिस नोड, और इस नोड का जिसको हमने डिलीट करना है, इसका एड्रेस कहाँ पे मौजूद है? इसका एड्रेस हमने डिलीट मी पॉइंटर में स्टोर कर लिया था इस लूप की पिछली एग्जीक्यूशन में. So we delete this node, we delete this node as well, ये दोनों delete हो जाएंगे। और हम फिर क्या कहते हैं, दिस नोड इज गोइंग टू बी डिलीटेड नेक्स्ट। सो इसका एड्रेस हम डिलीट मी पॉइंटर में स्टोर कर लेते हैं, इसका एड्रेस हम डिलीट मी पॉइंटर में स्टोर कर लेते हैं। एंड देन वी गेट बैक हियर, वी चेक इज करंट equal to null. If it is not, we enter the loop. So current अब भी null के बराबर नहीं है। So the first thing that we need to do is we say current is equal to current arrow next. So current को हम set कर देते हैं so that it points to 80, ठीक है। अच्छा, and then we delete this node, इसका एड्रेस हमने delete में पॉइंटर में स्टोर कर दिया था, ठीक है। और फिर हम क्या करते हैं, फिर हम डिलीट मी में मौजूदा करंट जिसको हमने नेक्स्ट टाइम डिलीट करना है उसका एड्रेस कॉपी कर लेते हैं, ठीक है। एंड देन वी गेट बैक एंड वी सी इज करंट इक्वल टू नल और नॉट, ठीक है। सो करंट में इस वक्त इस नोड का एड्रेस है करंट इज इक्वल टू करंट एरो नेक्स्ट, ठीक है। सो करंट इज इक्वल टू करंट, ये नोड अब जीरो तो नहीं है, ठीक है, इट इज़ नॉट जीरो, तो दिस कंडीशन इज ट्रू। कहाँ गई, सॉरी। So this condition current is not equal to 0, this is true. So we enter the while loop और हम यहाँ पे क्या करते हैं, we say current is equal to current arrow next. Now current arrow next is 0, तो वो 0 हो जाता है। और we say delete me में हमने पिछली इटरेशन में 80 का एड्रेस स्टोर किया था, तो ये नोड डिलीट हो जाएगा। एंड देन वी से delete me is equal to current. So delete me में हम करंट की वैल्यू स्टोर कर लेते हैं which is 0. So the next time we enter this loop, so current is equal to 0. This condition is false, so we get out of the loop, ठीक है। We get out of the loop. हमने तमाम नोड्स को डिलीट कर लिया हुआ, ठीक है। So this code it will delete all the nodes and this is in the destructor, so it is automatically going to be invoked जब भी हमारी सिंगली लिंक लिस्ट जो है वो आउट ऑफ स्कोप जाएगी। तो यहाँ पे ये ज़रूरी था क्योंकि अगर हम इसको फर्ज किया वो करते हैं for example, if we run this program and then this program stops executing, so we need to have the destructor so that वो automatically इस सिंगली लिंक लिस्ट को डिस्ट्रॉय कर दे, ठीक है। नाउ लेट अस रन दिस कोड। इसमें ये इंसर्ट का जो इसको मैं 5 मरतबा हम रन कर रहे हैं, उसमें कुछ डेटा इंसर्ट कर रहे हैं और सब तमाम डेटा जो है वो पोजीशन नंबर 0 पे यानी बिल्कुल एट द स्टार्ट हम इंसर्ट कर रहे हैं। तो नया जो डेटा है दैट वुड अपीयर एट द फर्स्ट पोजीशन। And after each insert operation, let us print the linked list. ठीक है, let us say s1 dot print. This is not s1, sorry, this is sl. इसीलिए वो appear नहीं हुआ, this is sl. So sl dot print. So let us print this linked list after each insert operation. So let's see कि ये कोड काम करता है या नहीं, ठीक है। So कंपाइल कर लेते हैं इसे। अच्छा जी, सिंगली लिंक लिस्ट डज नॉट नेम अ टाइप, friend class singly linked list, singly linked list, ठीक है। अच्छा अच्छा, it compiled fine, good, let us build it. Okay जी, now we have some problem. Expected this before this is in delete, ठीक है। तो यहाँ पे हम क्या कर रहे हैं, if find, अच्छा, so node current, invalid non-constructor this, so maybe problem is here, ठीक है। So this is a pointer, let's say we return it like this, or maybe we'll return it as a pointer in order to save time, okay. Compiles, let us build it. अच्छा, So that was fine. Now this is delete. So this is the contents of dereference कर रहे हैं. So we are going to dereference the pointer and return it as a reference. अच्छा जी. Let us build it. Again, this is which function? Single linked list. Delete. Okay, let us for the sake of simplicity, if I have time, we don't have time in this lecture, okay, let me make it a pointer and see if it works. Let us make it a pointer, okay. So we are simply going to return this pointer. So this would be pointer to a singly linked list, and we are going to simply return this. Similarly, this is going to be pointer to the singly linked list, and we are going to return this. Fine. This. Set. Delete. Okay, let's see if it works now. Let us build. This is delete. Expected this, revert this. If find, this is fine. This is fine. While, actually, we are missing one here. Actually, let's try again. Compile. Build. Okay, it built fine, and let's run it. Okay, so this is S1, size of S1 when we initially created it. It was, how much was it? So it was basically 0, okay, initially. Then we inserted data into it, and after each insert operation we did printing. The print function needs to be modified a little bit. Once the list is printed, we need to print an end line character, so the next time this function is called, we can see the output on a separate line. Okay, so cout the updated list, and then there. Okay, so let us build and run this code. So this is initially the list that we created 0, then we started inserting data. So the first data that we inserted was I is 0, so I square is 0, so 2. The next data item that we inserted was I is 1, so 1 multiplied by 1 is 1 plus 2, 3. And we inserted it at position 0. Okay, so the first position. Every new entry would appear at the very beginning of the list. Okay? And after each insertion we are updating it. After each insertion we are updating it. Okay. So let us make it say 10. And once we do it, let us say we want to know the size of this list. Okay. So let us build and run. So after 10 insertions, okay, so 1 2 3 4 5 6 7 8 9 10. So this is the size of the list. Now let us call the other version of the insert function. So for example, now after this loop has executed, it will have 10 elements. Okay? So let us insert a new element. Let us say sl.insert, and let's say this is capital insert. Let's say we want to insert a new element after the 5th position, and that element is, say for example, 1000. Okay, that is what we want to do. And after that, let us say we want to print the updated list. After insertion after k is equal to 5. Okay, so I'll demonstrate this one insertion at any other position than the initial k is equal to 0 position, and then I'll also demonstrate a deletion. Okay, so say for example we want to delete, we want to say sl.delete, delete the 8th element. Okay, and return the deleted value in this variable data. That is what we want to do. Okay, and then we say sl dot print, and we say the updated list, after deletion of 8th element. Okay. Let's see if those functions work fine or not. So let us compile this code and build and run it. Okay. So this is the list after the 10 insertions. Then we say after the 5th element we want to insert a new element, 1000. So these are 1 2 3 4 5, fifth element, and after 5th we inserted the new element with data equal to 1000. Then the 6th element and 7th and 8th and 9th and 10th, they appear in their new positions. Then we want to delete the 8th element. Now this is the updated list. What is the 8th element? This is the 6th, 7th, 8th. 8th element is 11. So we need to delete 11. Once it is deleted, then after 18, 6 would be the next element, and that is what it is. Okay? So in this lecture, like, we implemented this singly linked list class, and we implemented all its operations. We don't have time to discuss these circularly linked list and doubly linked list classes. So we'll discuss these in the next lecture. Until then, you should write the code that we created in this particular lecture, and you should clearly understand how to use these pointers and how to create these links between these nodes. Okay, so we'll try to go through a couple of more coding examples, and I hope that would help you understand, like, how do these linked lists work. Okay, until then, Allah Hafiz.